Lesson 6-2, Substitution. Our essential question today is how do you determine what to substitute in a system of equations? We have one new vocab word today, substitution. What substitution means is when you replace one thing with another that is equal in value. A really common example of substitution would be working with money. A lot of times people ask for change for $1. So maybe $1 is the same as 4 quarters, or 10 dimes, or 20 nickels, or 100 pennies, and so on. That's substitution. If you replace $1 with 4 quarters because they're equal in value. Another example in a school would be when a teacher is gone, a substitute teacher comes in to replace them and teach whatever that teacher was supposed to be doing that day. Okay, our first example, use substitution to solve the system of equations. Y equals 2x plus 1 and 3x plus y equals negative 9. What I want you to look for is a variable by itself. So look for a variable by itself. That is the variable that we will replace. The lonely variable. So I see a variable all by itself, and it's the y. So in my first equation, y is equal to 2x plus 1. So I am going to take that 2x plus 1 and I am going to put it where the other y is. Because y is the same. The first equation tells us that y is the same as 2x plus 1. So that means that I can replace the letter y, and in its spot I can put 2x plus 1. Now the rest of the equation stays. So I have 3x plus 2x plus 1 equals negative 9. So look at what I did. I replaced the letter y, and in its spot, I put 2x plus 1. Now I can solve this equation. 3x plus 2x is 5x. 5x plus 1 equals negative 9. Then I subtract 1. So 5x equals negative 10. And then I can divide by 5.
Miss Horton, if you're still in the building, please dial 6803.
And
Miss Horton,
x
6803. Thank you.
negative 2. So the x coordinate for my solution is negative 2. I still need to find the y coordinate. So I'm going to take my negative 2 back up to the top. And x is equal to negative 2. So I'm going to replace the x right here with that negative 2. So y equals 2 times negative 2 plus 1. 2 times negative 2 is negative 4, plus 1 is negative 3. So my ordered pair solution is negative 2, negative 3. So if we graphed these lines, that's where they would cross. So these lines are intersecting, there's one solution, and we have found it. It's negative 2, negative 3. My next example, we are again going to look for a variable all by itself. In this case, it's the letter x. The letter x. The letter x is equal in value to 3y minus 2. So that is going to replace the other letter x. So 3y minus 2 goes in the spot where the x was. Then I've got plus 4y equals 5. I can combine the like terms 3y plus 4y is 7y. So 7y minus 2 equals 5. Add 2 on both sides. So 7y equals 7. And then divide by 7 on both sides. So y equals 1. On this problem, I have found my y coordinate first. It's 1. Now I take that back up to where I started, and I replace the y with a 1. So x equals 3 times 1 minus 2. 3 times 1 is 3. 3 minus 2 is 1. So my solution on this one is 1, 1. So again, if I graphed this system, we would find that these lines intersect, and they intersect at the point 1, 1, so there's one solution. My third example, I see the y all by itself, and it's equal to 4 minus 8x. This one's a little bit trickier because when I put the 4 minus 8x in for the y on the bottom equation, you may notice that there's a 2 in front. So what that means is I need parentheses around the 4 minus 8x. I need to make sure that that whole thing is multiplied by the 2. And then the rest of my equation, plus x equals negative 7. Okay, so now I'm going to have to do a very important step first. Distribute that 2. 2 times 4 is 8. Minus 2 times 8x is 16x, plus x equals negative 7. Combining my like terms on this one, I'm going to put a 1 in front. Negative 16 plus 1 is negative 15x. I've got my 8 in front, and it equals negative 7. So I subtract my 8, since it's a positive 8, to cancel it out. Negative 15x equals negative 15. Divide both sides by negative 15. And the x coordinate for my solution is 1. Oops. So my x coordinate is 1. I take that one up to the beginning and plug it in. You can substitute the 1 for x in either one of your equations. I like the one that I substituted with in the first place because that one's already solved for the letter y. So y equals 4 minus 8 times x. 8 times 1 is 8, so 4 minus 8 is negative 4. So my ordered pair is 1, negative 4. What you should notice today is that we are always working with intersecting lines. We will always have one solution, and we will find that ordered pair. So all of your problems today, that's what you should be expecting. All right, our next example, x equals, so x is by itself. I replace it with 4y minus 6, so it's got to go in the spot where the x is. So 5y plus 3, and then in parentheses, because of the 3, where I circled that x, I'm substituting to replace the x, not 3x, just the x has a value 4y minus 6. I need to distribute. So 3 times 4y is 12y. 3 times negative 6 is negative 18. And I've got a 5y over here, so I need to put a plus in front. Combining like terms gives me 17y minus 18 equals negative 1. Add 18 on both sides. So 17y equals 17. Dividing by 17 gives me y equals 1. So my y coordinate is 1. Bring it back up to the top. X equals 4 times 1 minus 6. So x equals 4 minus 6, which is negative 2. So negative 2, 1 is the solution to my system. Okay, our last example looks a little bit different because there are two variables all by themselves. I'm going to pick one of them, and I am going to see what it's equal to. So y is equal to 2x minus 4. So that 2x minus 4 replaces the other y, and it gives me an equation that has variables on each side. So I cannot combine them together on this one. I have to subtract one of them from each side. So this is different from all of the others that we've seen on our lesson. So 3x minus 2x is 1x. Then I subtract 1 on each side. So 1x equals negative 5, and 1x is the same as x. So x equals negative 5. So negative 5 is my x coordinate. And then I go back up to the top and plug it in. Y equals 2 times x minus 4. 2 times negative 5 is negative 10. Minus 4 is negative 14. So the solution on this one is negative 5, negative 14. So substituting on this problem gave us a variable on each side instead of having our like terms on the same side. So you just have to be careful with your substitution. Look for a letter by itself. Whatever it is equal to is going to replace that letter in the other equation. You should be able to write your summary now, answering the essential question. Make sure that you use complete sentences.